Okay, hello everybody. Welcome to General Science. We will be covering a little bit of chemistry and physics in this class. Now keep in mind when we are back in the classroom, it's generally set up where I do 2 hours, sometimes I spill over a little bit, with math, and then the remaining 2 hours with science. Okay, so we'll be looking at probably about the first 6 to 7 days we'll be doing chemistry, and then the remaining time we'll go into physics. So we kind of cover quite a bit of material. We don't dig really super deep yet. It's just kind of a general overlay, I guess, of just all different types of subjects for the most part of the science. I'll let you know when we're getting a little bit more deeper. So when you initially look at it, it seems like, oh my gosh, what all are we doing? But we'll just take it off a piece at a time. When we look at the syllabus that you'll find underneath your course, you will see that exams make up 30%, homework is 20%, your PPS is 15%, which is required for all first semester students. Justin kind of touched on that today during our meet and greet as far as what those expectations are. We'll go over them more again when we're back in the classroom. And then your final exam will be 35%. And the grading is still the same. That's PIMA guidelines are 93 to 100% is an A, 85 to 92 is considered a B, and 77 to 84 then is a C. So you need to maintain a 77 or above to be passing. Alright, so if you look at for today, this would be, I mean, you may be looking or listening to this lecture a day before. You'll go under course content, and then you'll click under chemistry, and then you will open up day 1, and then you will see that there are several things posted there. You have the PowerPoint day 1. That very first one that's listed is not the YouTube one. It's not the one that I'll be posting here after I'm done recording this. I put a link for you guys to listen to it. The very first one though on here is the one that we would normally be going over in class. It should be identical. The only thing is that if you view this one, it has more clickable links, I guess I would say, for the YouTube videos that are maybe supplemental videos to explain things, and I think I might have 1 or 2 on this one. So I always tell the students to kind of go back, especially in my CV diagnostics right now. There are a lot of speaker notes at the bottom of the slides that they're kind of used to viewing, and we'll go over all that when that's necessary. You also have a link to the periodic table of elements that is all in colored format. If you're able to print it in color, that's great. If you can't, I would recommend doing it in black and white and coloring it in yourself so you can kind of group the families together. And then you have a couple other documents there that are more information about the periodic table, kind of explained, and then the item in red is your homework, is your assignment. So that will be due on Friday, and it's a scavenger hunt. So, all right, so we're going to go ahead and move on to chemistry, day 1. And just going to give you a little bit of information, a little bit of background information on the periodic table of elements. Don't worry about this particular information on this slide. This is just some information that I found out. I actually used my son's high school chemistry book because we do not have a textbook, unfortunately, for some of the basic stuff. So I'm just going to kind of give you a little bit of a little history here of the periodic table. So it was originally designed to represent the patterns that are observed in chemical properties of elements. And in the 18th and 19th centuries, it became evident that the Earth was composed of many elements with different properties. So these two gentlemen, Meyer and Mendeleev, kind of conceived and formed the present form of the periodic table. In 1872, which is pretty remarkable when you think about it, the Mendeleev man was the first to publish his table. and he had elements, gallium, scandium, and germanium were actually unknown, but he predicted that these were going to be in existence, and so he kind of made gaps in the periodic table, kind of anticipating that these were going to be discovered based on the patterns that he was finding. So here again is your one of your views. Actually, the link that you have is a little bit different, but it's similar in the fact that it's colored and has the groups and stuff. So, and this kind of gives you the codes, and so does the other one as far as if they're metals, what type of metal they are, if they are non-metal, if they're metalloids, halogens, noble gases, and we'll talk a little bit more about those here in the upcoming slides. All right, so the table itself is kind of organized in either they call it groups or families. Okay, I know the one resource that I gave you, I think, refers to them more as families, but they're also considered to be groups, and these have similar chemical properties. Okay, so they are within families or again groups, and I did include a link on this slide, on this presentation, for Khan Academy. I think it's about 8 or 9 minutes. So again, if you view the first PowerPoint, day 1 PowerPoint, or you can just Google Khan Academy periodic table of elements, they kind of explain it a little bit more in detail and kind of how they differentiate them. So just be familiar that groups are families and are vertical, up and down. Okay, they have similar chemicals, and then periods are the rows. Okay. All right. So when you look at each one of the elements, there is a letter in each of the boxes. Okay, and so the letter, and you may remember some of this from high school. For some of you, maybe longer than others. So you have the letters, and the letters are basically a symbol for the elements, and in many cases it's an abbreviation of the elements' names. Sometimes it's similar letters, sometimes it's not. Then the number shown above each symbol is the atomic number, which is the number of protons for that element. And then the number below each symbol is the atomic mass. So this particular picture here is exactly a screenshot of one of the handouts that I have included in day 1. So go ahead and study this so you're familiar with all the terminology here, because you will be asked these questions on upcoming tests. So when we look at the atomic number again, that's going to equal the number of protons that are in the nucleus, as well as the number of electrons in the electron cloud. And then we have the atomic mass, which is the number below, and then also the name's always on there. So C for carbon is the weighted average of the masses of all the elements isotopes, and we'll be defining this more on the next lecture as far as what all these terms mean again, because I know it's been a while. And then again, the symbol is generally a 1 or 2 letter abbreviation derived from the element's English or Latin name. So that's why sometimes it doesn't make sense on how they pick those abbreviations. Alright, and so here is your video link. Actually, on this one it looks like if I were to click it, it would work. Sometimes they do and sometimes they don't. If it looks like it's going to work, then fine, but be all stop it, pause this, and click on it. If not, you can resort back to your Blackboard and view it that way. So this is that Khan Academy link that I was talking about. Alright, so like I was saying, they are kind of grouped in different categories. Metals being one of them. Metals versus non-metals, kind of just defining a little bit of both of them. Metals, remembering, are good conductors of heat and electricity. They're malleable, meaning that you can kind of hammer them out in maybe thin sheets or whatever. I know I do a little jewelry on the side, and I like to work with copper, and you can hammer it and get little dimples kind of on it to give it a little bit more definition, dimension. Metals can also be formed into sheets for making cars, pulled very thin into making wiring, and they are also reactive. Sodium and potassium are some of the most reactive of all metals. Okay, so you might want to remember that. Most metals are solid at room temperature and always tend to be kind of shiny. Okay, one metal here that maybe you'll think of is a metal that is liquid at room temperature, and you can tell what temperature is with this metal. So hopefully you're saying mercury. So non-metals are usually poor at conducting heat and electricity. They're not malleable, and many are gases at room temperature. Some are solid and some are also liquid at room temperature. So here's a picture, a little snapshot of some different non-metals. Metalloids, these have intermediate properties, so they're kind of a mix between metals and non-metals. Some can be made to conduct electricity, and we call those semiconductors. Semiconductors are used to make computer parts and other electronics. So you have kind of a black line that separates the metals from the non-metals. Okay. Remember, although hydrogen is touching metals on the chart, it is a non-metal. So here are some examples of metalloids. Boron is one. Silicone, used a lot in tubing for healthcare products. Arsenic, and germanium. Metals usually make positive ions when dissolved in a solution, and their metal oxides then make hydroxides when they're in a solution. So when you think of the word hydroxide, you think of water as hydro, and then ides are made up of two different elements. Sodium chloride dissolved in water makes N-chloride dissolved in water makes sodium chloride, and that's our saline solution, and we use it in the body to replace. We use it as a replacement for our body sodium in the 0.9% solution for sodium chloride. KCl, for those of you that might remember, K, or maybe you're not, it's always kind of hard. I always think of teaching first semester to you guys as in a way of not knowing what everybody's background is. So forgive me if I kind of compare it to kindergarten. I taught kindergarten, full-day kindergarten for 3 years, and I always enjoyed it because you never knew what you were going to get. So you had some kiddos that could write their name and could follow directions pretty well, and were pretty, or could even read a little bit, and then you had some that didn't. They didn't have any preschool experience. So I enjoy the challenge. I like seeing people's different abilities coming in, and what they can contribute, and what they have to gain, and kind of everything in between. I compare it to the first semester, especially because healthcare, as we dig deeper here, it's kind of a different language in itself. I mean, we have our basic stuff here with some of the math and science, but as we dig deeper, depending on what kind of background you come from, this is like the whole thing is a foreign language. I mean, some of this you've heard as, from high school stuff, but if you haven't gone, to school beyond that, or even if you have, we will definitely go and touch on things that, or dive into things that you have never heard of before. So anyway, bear with me. I like to get off topic sometimes. Anyway, so KCl is potassium chloride, and we use potassium chloride to help treat low levels of potassium. Big surprise. So hypokalemia, okay, is what that's called, or hyperkalemia. So you either have a low level of potassium or a high level of potassium. We have developed low levels of potassium if you have a case of bad diarrhea or vomiting, or even medications can cause a low potassium, such as diuretics. So a lot of people, if you know, unless they're on a potassium sparing diuretic, have to take a potassium supplement because it actually eliminates potassium. All right, alloys. So again, we're talking about the different groups in the periodic table. Alloys are metals that are easily combined. So mixtures of many metallic elements are called alloys. So steel, copper, aluminum, nickel, magnesium. And these generally make the metal stronger and also can make them lighter. So for example, the chassis in vents are typically alloy, and they can make those units a lot more portable. And probably, I'm sure, a lot of our computer parts are the same way. All right, so what makes metal stick to an MRI machine? Well, MRI is basically a big magnet, okay? So it has a huge magnetic field. So it's called ferromagnetic, okay? Non-ferromagnetic can still actually cause disturbances in the magnetic field. So even though braces are considered stainless steel or titanium, they can still create enough artifact to kind of mess up with brain scans. Ferrous just means consisting of iron. Electricity can also alter an image on an MRI. So just have to be aware of when we go into MRI machines that we don't have anything metal on us, because it can be extremely dangerous. We don't want to have any scissors in our pockets, pagers for phones, watches, oxygen tanks have iron in them, and now we make them with aluminum, and so they don't go flying through the air. So we have a lot of our all of our equipment that we take into the MRI scanner has to be MRI compatible, including our ventilators. But you'll learn a lot more about that down the road, so I'm not going to spend any more time about that. All right, moving on to subatomic particles. Okay, so over the next couple of days, we'll be kind of breaking all these parts down again, and defining, what is an atom, what is the proton, neutron, electron. So this is just kind of a preview, basically, of coming attractions. So subatomic particles, what is that? It's a particle that is smaller than an atom, like a neutron or a cluster such particles. Typo there. So we have protons, neutrons, electrons, and then the nucleus that all make up an atom. So like I said, we'll be spending some more time on this in more depth. The metric system. This is definitely something you'll be using if you haven't used it much before. I think it's a lot easier to use. We'll be looking at meters and liters and grams. So these are units of measuring length, capacity, weight, or mass. Here's a little conversion factor for you, or scale. I'm at a loss of words. I feel like I've been talking all day. This is like a full day lecture day for me. Good thing you guys have me in the morning. I'm usually a little more fresh in the morning. This is in the afternoon now for me. So some of the ones that you'll be more familiar with, or that you'll want to know, is like a kilogram equals 1,000 grams, 1,000 mils equal a liter, and we'll have lots and lots of time to practice on this. So this definitely overlaps with our math too. Some of the more customary conversions, an inch, and I would say, I don't know, that one I have memorized. I don't know why an inch equals 2.54 centimeters. I guess maybe because we measure a lot of things in centimeters, like the length of an ET tube is always measured in centimeters. So that's probably one you want stuck in your head. You also want to know that 2.2 pounds equals 1 kilogram. That is actually not on there. The flip-flop of that one is on there. But again, 2.2 pounds equals 1 kilo. And about 30 mils or 30 ounces, so an ml, milliliters, an ounce is the same thing, okay? So 30 mils, oh, I'm sorry, I think I just said that wrong. No, so 30 mils is equal to 1 fluid ounce. What I meant to say is milliliters are equal to cc's, cubic centimeters. Okay, so if you were to take a cubic centimeter and square and cube it to make it like a little cube, a centimeter cubed, it would be equal to a mil. So I got kind of off track there. So a cc is the same as a mil, and there's 30 mils in 1 ounce. Okay, this is also a conversion table that you will find, and I know I have a hard copy of it. Hopefully you can print this. It might even be actually coming up. It's either, I think it's coming up here in a couple days, but I do know I have this in a bigger format that you can print it, which also is some of the conversions. So we will definitely be doing the conversions again in math. Looks like Justin just put up a link for your textbook for math, so that's great. That's good news. So if you look at pages 101 to 108, that can help you with some conversions. And then in your Egan's textbook, I'm not sure if you've gotten that yet, but in chapter 6 there's also some conversions in there. And this is my reference from the textbook that I used. So email me with any questions. I know this is really difficult to do online. Again, this is the first time I've had to teach the math and the science online, and I think it's especially hard when you don't know me. My classes, my groups that know me from before, they're kind of more familiar with my sense of humor and how I talk and how I ramble. They kind of get it, but you guys are just, I think it's unfortunate for you to have to be subject to this in this format. So for Friday, what is due is your periodic table of element scavenger hunt. And I'll look forward to seeing you all again on Friday. And please email me with anything. Have a good night. Thanks.